Am I?
Yeah, you are.
Okay. So don't forget, when you have a parentheses in here and a number on the outside of the parentheses, everything in the parentheses now has to be multiplied by 2, but not the BA, only the stuff inside the parentheses. So that can be a little bit tricky. That's the only one. All the other ones I think are straightforward, right? You know that if you have a little 2 underneath the CU, to the right of the CU, that means there's 2 CUs and only 1 O. You guys know that. Diatomic element means 2 N, so N2, diatomic, di meaning 2 atomic atoms, nitrogen, N2, so it'd be 28. Again, here's one of those parentheses deals. Careful. That one's straight up. Okay, some work to do also. Okay, so chemistry of cooking, right? So we're going to start with hydrocarbons. As you can imagine, hydrocarbons are a type of molecule that has hydrogen and carbon. That's all, hydrogen and carbon. All right, so we're going to start with the cooking part of chemistry of cooking. So the actual cooking. So when we cook, we have to have heat. And if you have a gas stove at home, oftentimes they use natural gas. Natural gas is mostly made up of a gas called methane. Methane, the formula is CH4. We've talked about it many times in this class. Or you can see here is the structure for methane.
Weldon?
Yes?
You kicked out Mackenzie. You gotta let her back in.
I just let her back in. Yeah, she's
Okay.
back.
All right, good. All right, so how do we name the molecule methane? Why is it called methane? Naming of the hydrocarbons is in 2 parts. One is the prefix and one is the suffix. Those are the 2 parts. And we have to use tables P and Q for this. Well, don't have to, but those are the tables you want to use if you don't memorize the whole reference table. So if you guys still have your reference tables out, I would open them up, but I do have them here, but they're pretty small here. All right, so methane naming, right? This molecule here, as drawn, has 1 carbon. So the prefix for 1 carbon in table P is meth. This molecule, as drawn, has 4 single bonds. So if I use table Q, all the ones with single bonds end in the syllable ane. Alkanes are all single bonded. So the example they give you here is ethane, but it's all single bonded. So when I put 1 carbon and single bonds together, I get the word methane. All right, let's continue. That's the naming of a hydrocarbon. Now we're going to do the reaction of the hydrocarbon to make fire. So it's called a combustion reaction. We've talked about this briefly before. It is a redox reaction. And the overall formula for combustion reaction is, let me do something. Sorry about this. I don't know, Miss Milsom, can you start the recording? If you can, try it. Anyway, the overall reaction is fuel plus oxygen gives you carbon dioxide and water. So any combustion reaction is always going to be that basic formula. Fuel plus oxygen gives you carbon dioxide plus water. So the fuel in this case is methane, CH4. The oxygen, O2, right? Carbon dioxide is CO2 and water is H2O. And these the 2's in front of these 2 things is just balancing the equation. When you have a combustion reaction, you always have heat. You guys know that. Something combusts, you're going to get heat. You don't necessarily get an explosion, but you do get heat. So that's why on this fire, it gets hot. Okay, so, well, Miss Weldon says it's a redox reaction. You guys know that if it's a redox reaction, oh, thanks, Miss Milsom, that we have to have a change in oxidation numbers. One has to go up and one has to go down at least, right? So I wrote up the oxidation numbers here, which I know you guys can do, but I did it for you. So we see that H stays the same. Carbon goes from -4 to +4. That's going up. So it's oxidized. Oxygen goes from 0 to -2. So it's going down. That's reduced. And to balance the charges, if I did this right, I had to put 8 electrons. 8 electrons on one side, 8 electrons on the other side, right? So those are both, those are balanced by charge. Not really totally balanced. I didn't totally balance the oxidation reduction half reaction, but you can see that that one's oxidized and one's reduced. So a combustion reaction is a redox reaction, and it always follows this format. Fuel plus oxygen gives you carbon dioxide plus water. Okay, so we know that for the redox reaction, for the combustion reaction, we get heat, but how much heat, right? How much heat are we getting? So you can tell by this equation, 1 mole of methane will give you so much heat. And if you look at table I, like indigo, you can see this has a limited few amount of heats of reaction. But for methane, it does show the methane gives you 890, can you mute your microphone? 890.4 kilojoules of heat energy, right? Methane. Now the one underneath it, C3, you remember our naming protocols and look at table P. C3 will be prop, so that's propane. Propane will give you 2200 kilojoules of heat per mole. So table I can tell you how much heat is generated by at least those 2 combustion reactions. All right? Okay. So now we've got the naming of it. We know it's a redox reaction. We know which is oxidized, which is reduced. We know we can create heat. If we create heat, is it going to be exothermic or endothermic? Well, it's exothermic. If we produce heat, it's exothermic because heat is exits from the reaction, right? If we need heat or it's part of the reactants on the other side, then it's endothermic because heat goes in. So this is an exothermic reaction that produces 890 kilojoules of heat energy. Okay, so that's basically like the whole kit and caboodle for methane, right? Just a few additional points, FYI, things that you'll need to know. All organic compounds have carbon in it. So if you're asked on the regents, which they sometimes do ask, which element is required for an organic compound? Carbon. Some resources or texts say carbon and hydrogen, but it has to be carbon. And I already said this, hydrocarbons have only hydrogens and carbon. Hydrocarbons have hydrogens and carbon only. The carbon atom is so unique. That's another one of my favorite atoms because it has 4 valence electrons, and therefore it can bond to 4 different atoms and have 4 bonds to it. So there are just a tremendous amount of ways that you can combine carbon atoms with stuff. So I don't know, it's like one of the it's one of the elements that have the most amount of different molecules that it makes. So really, really interesting. But it has 4 bonds, always 4 bonds, remember that. For the homework that I'm going to give you, or no, for the lab that I'm going to give you tomorrow, I just wanted to show you a few different ways to show the structures. So you've seen the one on the top, which is just kind of like a stick figure, right? 2-dimensional stick figure. In the past, when we did our modeling lab, we made a ball and stick models of molecules, right? Remember this? For a 3-dimensional view. this one below here is another three-dimensional view instead of a ball and stick where you see the bonds here. It just shows like kind of the clouds of electrons here. Underneath it is the written name and the chemical formula, CH4, right? So the 5 different ways of saying the same thing. In the center column, 5 different ways of saying ethane, a different molecule. Actually 6, because I wrote the chemical formula in 2 different ways. And the next one is 5 different ways of saying, what's this, 1, 2, 3, pentane, pentane. All my stuff is blocked, so that's pentane.
Miss Walden,
Yeah,
on pentane, why does it have CH3 and then like why does it have CH2 written out 3 times rather than just doing like CH2 in parentheses 3?
you could do that, absolutely. So you could have CH3, parentheses, CH2, yep, it's B3 with a little 3 on the bottom after the end of the parentheses and then another CH3. Absolutely, that's totally fine as well. Yep.
Oh yeah,
you-
time to go.
Oh, shoot. All right. And the last page here, wait, just give me a moment. Is a skeletal format. What? And super quick, this one I want to say that each end piece and each corner piece is a carbon, and each carbon has to have 4 bonds. I'll go over this again. And here, do this practice sheet.
Miss Walden?
Yeah.
Are we good to go?
As soon, if you go through the thing, if you go through the PowerPoint, try this practice sheet and I'll kind of review it tomorrow.